This course is about designing a landscape drainage system for a residential property. We'll address the process and principles of stormwater management and talk about how to select the right components for common landscape draining problems. To begin, we'll consider the reasons for installing drainage and how to assess the draining problems on site and gather the information you'll need to complete the design. From there, we'll discuss how to select the proper drainage method and equipment for the application, and how to calculate flow rates to size the system to meet the site's drainage needs. This whole process will lead to a design for the components needed to resolve the problems identified. Drainage is the hidden secret to a beautiful and healthy landscape. But let's face it, it's not always the first thing customers think about. They're dreaming of beautiful plants and outdoor living spaces. Your job as a professional is to remind them of the need to protect their outdoor spaces from drainage problems. In some cases, drainage can be a problem solver for existing issues. Your customer will complain of water problems like puddles, persistently wet areas, erosion, runoff, water intrusion into structures, wood rot, dampness in buildings, wet basements, and other problems caused by excessive stormwater. When there are water problems on a property, customers need solutions fast. They will prioritize their spending to solve water problems that prevent them from enjoying their property or that might damage their home. In fact, surveys show when there is a drainage problem, customers will prioritize fixing it over all other landscape improvements. For the forward-thinking landscape contractor, drainage can also be a proactive recommendation as part of a larger landscape project. It's often easy to install drainage when the rest of the landscape is under construction, and the added cost is minimal. In addition to protecting structures on the property, well-drained soil promotes healthy root growth and stronger plant material. Additionally, drainage can be a profitable add-on to a larger project. Because the installation crew is already on site with equipment necessary to install drainage, the contractor can capture additional sales dollars easily. There are three main questions to ask when assessing a site for drainage problems. Number 1, where's the stormwater coming from? Number 2, where's the stormwater going? And number 3, where is it inappropriately collecting or doing damage? The goal of a drainage system is to move runoff from the source to the discharge point, directing it away from places where it sits or does damage. In a typical residence, runoff comes from several sources, including the roof and guttering system of structures, sidewalks, driveways, and other impermeable hardscapes, sloped areas from neighboring yards, any other runoff areas. Remember that stormwater runoff doesn't obey property boundaries, so look beyond the property lines to identify all water sources. To determine where the water is going, follow the contours of the landscape that help water drain from the property. Drainage systems should avoid charging water onto another person's property or into a sanitary sewer. Discharge points should either be natural capture locations like ravines, creeks, ponds, or lakes, or built systems designed to channel water like streets, retaining ponds, dry basins, drainage ditches, swales, infiltration systems, etc. I really could go on. To determine where the water is collecting or doing damage, be on the lookout for the following. Low points in the yard where water might pool or that may remain damp after heavy rains. Areas that show signs of erosion. Grades that slope towards the house. Any problems identified by the owner. Also, pay attention to common causes of drainage problems, including poor grading. Note there are grading problems that can be solved and those that cannot. In most existing landscapes, it is too expensive or too disruptive to correct drainage issues through regrading. Large areas of pavement and structures on the property. Walls, plantings, roots, and curbing that direct water in specific ways. Runoff from adjacent properties with any of these problems. In order to design the system, you'll need several pieces of information about the site, including soil type, grade, runoff points, and your notes about specific problem areas. One of the most important considerations is the soil type, because different soil types have different infiltration rates. The infiltration rate is how quickly water can be absorbed before it begins to run off. Certain soils are more porous, so they can absorb more continuous rainfall before water begins to puddle on the surface or run off. Clay soil has the lowest infiltration rate, and sandy soil has the highest. You will want to test the soil in several areas of the landscape to find out what type of soil is present. This is important because you will need to know this as a key factor in sizing and placing drainage components. Here's how to do a simple soil analysis. Take a fistful of moist soil, squeeze it in your palm, and then open it to examine the soil. Clay soil will form a ball that will not break when poked. Loamy soil will form a ball that will break when poked, and sandy soil will crumble without being poked at all. Clay soil will have the lowest infiltration rate and therefore the most runoff. Note the soil types on each area of your diagram so you have them later for when we size components. Drainage is also affected by the subsoil. If there is a layer of clay a foot below the surface, for instance, it can prevent water percolation into the subsoil and can cause drainage problems on the surface, even if the surface level soil is sandy or loamy. This can be a problem on sites where soil has been imported to level the site or for landscaping purposes, covering a dense layer of clay on site before construction. When working with new construction, you might be able to access the builder's soil analysis for more thorough soil information. If the soil conditions on site are unknown, you can take a soil sample with a 3-foot or longer auger or soil probe. As you examine each area on your site, be sure to measure its slope or grade. To measure the grade, you'll need a laser level with a measuring rod. Different levels work in slightly different ways, but the basic idea is that you set up the tripod with the laser level so that the level is higher than the highest point you want to measure. Once you have adjusted the level, or waited for self-leveling models to adjust, take the measuring rod with the laser receiver to the top of the slope and adjust the height of the receiver until it beeps. Clip it in place and take the measurement. Use the measuring rod to measure the height of the receiver at the bottom of the slope, then subtract the measurement from the top of the slope from that at the bottom to determine the total rise over the slope. Divide this by the length of the distance between the 2 points and multiply by 100 to determine the percent grade of the slope. In order to turn your observations into a site plan for the design, you'll need to create a scale drawing of the property, noting all of the information identified above. It's important that the drawing be to scale so that you can calculate the amount of water the system will need to handle. The best place to get a scale drawing of a residential property is from a professional land survey. Your client probably received one of these when they purchased the house. It will show the dimensions of the lot and the placement of the house and other hardscape features. On larger custom homes, the architect or landscape architect may have prepared a site plan that includes information on the grading. You can also use online tools like Google Earth to become familiar with the dimensions and terrain on a property. If you have to create the plan from scratch, you'll need to determine the dimensions of the lot and then plot all of the objects on the property yourself. If you're working with a rectangular property, you can do this using a grid method. An easy way to do this is with a 250-foot measuring tape and some graph paper. Lay down your measuring tape along one edge of the property, usually the front street-facing side. This becomes the bottom edge of your grid. Walking behind the tape measure and looking straight back into the property, line up the edges of structures and landscaping elements with the marks on the tape measure. On the graph paper, mark the location of the edges of all major elements of architectural and landscape design, including the location of the house, driveway, sidewalks, pools, decks, or patios, and significant landscape elements like trees, shrubs, and landscape beds. Once you have plotted the corners and locations of objects relative to the front or street side, repeat the process with the measuring tape stretched along the side of the property at a right angle to the curb. You'll now have 2 coordinates for everything on the property, and you'll be able to easily draw the property to scale on your graph paper as you go. For houses with complex back or side yards, you might need to repeat the process along the back edge of the property and on the other side, but 2 passes are sufficient for most properties. In addition to the basic site features, note all of the items we discussed before. Slopes on the property with arrows indicating where the water flows, and identify the percent of grades for all major slopes. Sources of incoming runoff. The dimensions of the area on the property that are causing runoff to the problem areas. Soil types for all areas as these impact the runoff rates. Be sure to mark all problem or potential problem areas on the plan and indicate the size of the problem area. For instance, if there's a low spot on the lawn, outline the area that drains into that low spot. Finally, identify all discharge points or potential discharge points on the plan and relate these to the areas that could drain to that point. For instance, the front yard may drain to the street while the backyard may drain to a ravine or swale. If there is no obvious discharge point for an area, note that this can be resolved with a variety of solutions that we will discuss later. Once your scale plan has been made with all of this information, you are ready to design the drainage system. A drainage system needs to do 3 things: capture excess stormwater, convey it away, and discharge it safely. There are a number of products to serve each of these functions, so we'll discuss what needs to happen at each point in the system, and then consider more carefully how to choose the right product for a particular application. To start the design process, we'll make a provisional design by identifying capture and discharge points and mapping out a route for the pipe to convey water from collectors to discharge points. Water capture is done at low points in the landscape, where runoff flows into the property, or where large amounts of stormwater accumulates during a rain event. From downspouts at the edges of hardscapes or paved areas, etc., capture points will be sized to accommodate all of the water that could potentially flow during a significant storm event. Water is typically conveyed with pipe, either smooth walled pipe or flexible corrugated drainage pipe. Corrugated pipe is less expensive but requires a steeper grade. It is more prone to clogging and handles less well than smooth walled pipe. Your pipe size will be determined by the system's flow rate, which we'll calculate in a moment. There are 3 basic ways to discharge water conducted through the drainage pipe. First, you can simply daylight the pipe, extending it out of the ground and into a ravine or creek bed, for instance. Second, you can use a pop-up emitter that emits water during rain events, but closes it when it is dry to prevent clogging with debris or occupation by certain rodents. Finally, an infiltration system like a dry well infiltration trench or a stormwater chamber detains and infiltrates excess water underground, allowing it to percolate naturally through the soil after the rain event has occurred. There are different collector options to choose from for different types of situations. Let's review them so you're familiar with the different options to solve different challenges. In the landscape drainage world, there are 2 major categories of systems: surface systems and subsurface systems. Surface systems capture runoff as it moves across the surface of a landscape. A common example is using catch basins with grates. Water flows from the surface into the drainage system and is then conveyed to the discharge point. This is why they are called surface systems, even though the water is conducted underground. Subsurface systems are designed to collect water as it moves through the soil profile underground, which is why they are called subsurface systems. Water from the soil is captured below the surface and then conveyed to other areas. Subsurface systems address water problems in the soil, areas that are perpetually wet, and areas behind retaining walls or near the foundations of a house where water moving through the soil needs to be directed away from the structure. The most common type of capture device for surface drainage systems is the catch basin. This is essentially a box with a grate that collects water flowing into a low spot on the surface and transfers it to the pipe that conducts it to the discharge point. In general, catch basins extend below the point where the pipe exits the basin, allowing debris and sediment to collect in the basin bottom instead of flowing into the pipe where it could potentially clog up the system. To capture water under a downspout, a catch basin is the perfect solution. The grate keeps debris out of the drainage system, and a catch basin directly under the downspout quickly disperses runoff, preventing it from pooling around the foundation of the house and carrying the mulch for the landscaping all over your yard. Catch basins are also a great solution for low spots in the yard that collect water during rain events. Placing a catch basin at the lowest point in the yard captures water flowing across the surface of the lawn and directs it into the drainage system, preventing it from oversaturating the soil and ponding in the yard. For planter areas, courtyards, and planting beds isolated in concrete, catch basins are also excellent collectors. Installing an atrium grate instead of a flat grate improves their effectiveness in two ways. It keeps out mulch and other debris, and it increases the surface area of the grate, allowing more water to flow into the catch basin at one time than a flat grate on the same sized basin. Keep in mind that atrium grates are only suitable for natural or landscape areas, as the raised profile would interfere with mowers in lawns and people in paved patios or walkways. Catch basins can also be a good solution for paved or hardscaped areas when placed strategically at low spots on the surface. However, for these scenarios, especially on a surface like a driveway that is quite wide and instead of a low spot has a low-lying line across the paved surface, the channel drain may be a better solution. A channel drain is a relatively narrow capture device that can extend the length of a paved area, creating a large, linear capture grate that can better accommodate the sheets of water that flow down a driveway without the need to have the concrete slope to a single point. French drains are a solution for areas where water flowing under the surface of the soil is a problem, especially along walls and foundations where excess moisture at a considerable depth can cause problems. By giving excess water a place to go, French drains prevent the damaging consequences of prolonged water exposure to basement walls, foundations, or retaining walls. The next step in the design process is to size each component correctly so that the size can accommodate maximum water flow periods. Today, the calculation process has been greatly simplified by online calculators, so that all you need to know are the inputs for the online calculator, which quickly returns the flow rate and the amount of water you'll need to store in a seepage area. To use the calculator, you need to know two things: the square footage of the area to be drained and the coefficient of runoff. Most calculators use a built-in factor for a historic rainfall amount, often the 25-year average rainfall in a 30-minute period. Your scale drawing will be essential for measuring the square footage to be drained at each capture point, which can then be added together to determine pipe sizing for the whole system. When calculating the area to be drained, measure the total square footage going to a single capture point. You will need to know the drainage area for each capture device. And remember, drainage areas can extend beyond property lines, so don't forget to add an in-off-property square footage as well. The coefficient of runoff is based on the type of surface the water is running over. The calculator helps you out by listing surfaces for each runoff coefficient. For instance, 0.6 for clay soil. For impervious surfaces like roofs and the concrete, the coefficient will be 1.0. For highly permeable surfaces like grass, the coefficient is 0.35. This is where the soil type information noted in the site survey comes into play. You'll need to select the runoff coefficient that corresponds to the soil type on site. This information is crucial for properly sizing collectors and pipe. For instance, during a 3-inch rainfall event, a 1,000 square foot area of pavement will generate 31 gallons per minute of runoff, while a 1,000 square foot area of sandy soil will generate only 13 gallons per minute of runoff. Finally, to determine the 25-year rainfall for your area, you can consult the map provided on the calculator page. This map represents the rainfall intensity in inches for a 30-minute rainstorm event you would expect once every 25 years. Some jurisdictions may require you to design a different storm event, like a 5-year or 50-year storm, especially for new construction. Follow your local regulations where applicable. Now, once you have entered this information for the capture point, hit the calculate button, and you'll receive two numbers. The first, the flow in gallons per minute, and the second, the volume of water to be stored or discharged. The flow rate will affect the size of all components of a drainage system. On the collectors, flow rate will determine the grate size of the catch basin and the channel width and grate type of a channel drain. In high-risk areas, specify multiple catchments on lateral lines to create a backup should one catchment get clogged. Multiple catchments can also be used to capture water at multiple points along a slope, preventing water from building up too much velocity and causing erosion. For conveying runoff, the flow rate will determine pipe size, type, and slope of installation. Corrugated pipe can carry fewer gallons per minute than smooth-walled pipe, and pipe installed at a steeper slope will convey more water. Finally, discharge devices like pop-up emitters have flow rate limits, so you'll need to check that you don't have more water flowing to a pop-up emitter than it can handle. Let's consider an example problem and see how the calculator shapes our choice of capture, conveyance, and discharge options. So let's say we're trying to determine the drainage needs of the area outlined in blue. It's a front yard with a low spot in the center. Let's calculate the flow in gallons per minute. This drainage area measures 50 by 34 feet. That's 1,700 square feet. Enter this quantity into the drainage calculator. If the soil is clay, and we know that even under the grass there's a tough layer of clay, we can choose a runoff coefficient of 0.6 for clay. Finally, let's say that this house is located in Atlanta, where the 25-year rainfall amount is 2.5 inches. Punch the calculate button and see that the flow rate is 26.5 gallons per minute. If we're draining this area with a catch basin placed in the low spot, how big does the grate need to be? A quick peek at the 9-inch catch basins and their grates reveal that the standard square plastic grate will handle up to 114 gallons per minute. We'll specify a 9-inch catch basin with a square grate. We'll choose a green grate so that it blends in with the turf. Next, we need to determine the proper size for the flow rate. To do so, we can consult the following chart. The least expensive option is 3-inch corrugated pipe with a 2% grade. This will take a flow rate of 37 gallons per minute, well above the 26.5 gallons per minute our system requires. A quick note on pipe choice, however, there are two variables that affect the flow rate. Number 1, whether the pipe is smooth-walled or corrugated, and number 2, the slope of the pipe at installation. It is recommended that corrugated pipe be installed with a minimum 2% slope. You can increase the maximum flow rate of smooth-walled pipe by installing it at a 2% slope. Corrugated pipe is less expensive than smooth-walled pipe, and its flexibility makes it easier to work with in some ways. But the increased slope requirement and the need for potentially larger pipe can make it more expensive in the end in certain applications, so bear this in mind when choosing pipe for the system. Finally, let's suppose that we'd like to discharge the water using a pop-up emitter at the curb. Would a standard 4-inch pop-up emitter do the trick? A quick look at the catalog reveals that this pop-up emitter will handle 40 gallons per minute, so our drainage needs are within the limits of this discharge device. If we decide that it makes sense to limit discharge by adding an infiltration area, how do we know how big it needs to be? Once again, we can use a calculator designed to help us size the system. If we'd like to install dry wells, we can consult this flow well calculator. Entering the same data as before, the calculator returns the number of flow wells needed for the location, the necessary gravel to surround the dry wells, and includes installation diagrams. For this area, we'll need 5 flow wells and 5 cubic yards of gravel. To detain and infiltrate the total runoff calculated for the designed storm used in this example. In practice, it is rarely required to provide the full detention volume for a 25-year, 30-minute rain event. Check your local regulations for guidance on runoff detention requirements. Subsurface systems use French drains installed below the water table to capture excess water from wet areas or to provide drainage to an entire area, like a lawn. For a recreational lawn, a burial depth of 18 inches to 3 feet is pretty common, depending on groundwater elevations, with lines placed 15 to 20 feet apart. Drainage lines should be closer together in tighter clay soils and farther apart in sandy soils. The layout of the pipe depends on the application. For a subsurface system draining a few scattered wet spots, a system designed around the contours of the wet areas will do. If you are designing a drainage system for the whole area, a more structured design like a herringbone or a gridiron design is much more efficient. Pipe sizing is based on the area to be drained and the slope of the pipe installation, referred to as gradients in this application. You can consult product specifications for the proper pipe size for the application. 3-inch pipe is generally more than sufficient for lawns smaller than an acre. For lawn usage, pipe gradients vary from 0.1% to 1% and should remain constant over the run of the pipe, increasing, if anything, toward the outlet. Decreasing the gradient toward the outlet will cause a slowing of water velocity, which may result in silt buildup. Now that we have laid out the system by identifying capture points, mapping out the conveying pipe to the infiltration areas, and discharge points, and we have made the calculations necessary to size the capture devices, pipe, infiltration components, and discharge method, we are ready to complete our design. Draw in the location and clearly identify the size and type of all capture devices on the plot plan. If there are multiple catchments, make sure they are properly arranged on the plan and that lateral connections to the main drainage line are present. Next, clearly label the pipe size and type. To size the pipe for the entire system, you'll need to add up the liquid flow in gallons per minute coming from each capture device, and add up the total number of gallons per minute flow at each section of pipe. Then, consult the chart to select the pipe size for each section of pipe. And finally, identify the infiltration areas and discharge points on the design and specify the devices you will be using, a pop-up emitter, dry well, or stormwater chamber, or simply daylighting the pipe. If you are daylighting the pipe, consider using heavier duty pipe at the exit point from the ground and specifying a rodent protection grate. These steps will help prevent common causes of clogging at the discharge point. Laying down several feet of river rock riprap below the discharge point will prevent erosion and help keep the discharge point secure in its location. Once you have noted the capture device type and size, the conveying pipe size, type, and slope, and the location and types of infiltration areas and discharge points, your landscape drainage system is complete and is ready to be installed.